Hello again in this awesome tutorial. Today I will starting with you on your project with one of the famous data that we have in this field of machine learning and data science. It's the price house. That's mean based on some features we try to predict the price of this house. Well, as we know, in this project of data science, so the first tip as we should have is to look in a big picture of problem. That means the domain knowledge is necessary to have it. Well, I will show you now the tutorial. Discuss this piece of code we have writing with Python. But as I told you before, the domain knowledge is very necessary for if anyone can contribute to applying these techniques to solving this kind of problem. Well, so the first step we should have is a big picture. That means if we're facing the problem, we need to understand the problem deeply. Then we needed to reason what is the kind of feature we can use to solve this problem we have. So the second step is to get the data. So after understanding of the problem, the second step automatically is to get the data. So we need to collect the data. Maybe we can see that in some databases we have, or see some file like Excel file or CSV file maybe. So we need to have a strategy to collect the data we need. Well, the third step is to discover and visualize the data to gain insights. That means when we're collecting the data, we need to understand it deeply. We need to discover, we need to discover this strength of this data we have. Okay, so the third step is to prepare the data for machine learning algorithms. Well, the data we cannot find in the real world projects, it's dirty between brackets. That means we need the transformation. We need a phase, explore data analysis. We need to drop or replace the non-values. We need to convert some features because we can have some string features maybe and have some values with a string type. Well, our algorithms and machine learning cannot understand this kind of types we have of data. That means I cannot give a string value for my model. Cannot understand it with. So we need a strategy to convert this string to a value, numerical values. Okay, then after that, we can give it to our model to make any predictions. So the fifth phase, fifth stage in the process of machine learning project is to selecting a model and run it. Okay, we cannot just build in one model. So for this education purpose, we just trying to build in one. But in the real world project, we need to build in a lot of problems with different parameters. At this time, we can choose in just the best one, and after that, we can train it, test it, validate the data, and so on. Well, the sixth phase is the fine tuning your model. That means to find the best parameter tuning. We need to give for our model the best parameter unit, the best parameter we can have to make this good and healthy prediction of our data. Well, the seventh step or stage is to present our solution. Okay, after all the steps, we need to prove if the model is able to make add value in our process of management or any companies or something like that. That's when we have or we can extract add value from this model. The eighth stage of the eighth phase is to make that in the production. That means the deployment of our model. We're gonna make it in some cloud like AWS, Amazon, or Google Cloud. We have a lot of we have a lot of cloud can provide for us all the feature we can do. Blue Ocean or we have Heroku. We have a lot of clouds that can support our support or give us this ability to make our model in prediction. So as we see me now in this phase because I tried to divide in this tutorial in three or more, three or four maybe of videos just to not make it very long. So in this phase of analysis, I will start with you this pipeline of analysis. I show you some transformation of one video here to prepare our data for the prediction. So here, so in this income video, we will focus on machine learning pipelines customary on the life cycle of this line project. So this is really important for personally. We have not worked with data. So the name of this project is a house price. So advanced regression technique because here in this price, as we know, is a regression program. That means we have continuous values because the price can be changed. The price is not constant. Can be changed based on some features. Well, our role here is building a good model that help us to predict or forecast this price. Well, the mind of this project is to predict the house price based on the various features we will discuss go ahead. So, uh, source of data here is Kaggle. Okay, but we gonna have a lot of sources of the data. Okay, but one of the famous source of our dataset is Kaggle. Kaggle is a famous platform for computation of these scientists. Okay, but also we can have other sources like Amazon AWS dataset. Also, Amazon provide for us this repository of dataset. We have also data portal. We have Open Data Manager. We have Kindle, one of the famous source. Also, can join it with Excel to work with. Kindle, famous one. We have Cora. So here for this repository, also we can have that. Around so for questions. Okay, and we have also this Wikipedia is machine learning datasets. So source of data not for now is not a problem. Okay, just we need to focus on our problem. Try to understand deeply what we can do to solving or to find the best version for our model. Well, let's continue now with this data set we have. Well, this is all the phases we have here in this life cycle on our project. So the first tank is the data analysis. I mean, we try to analyzing the data to extract more information. So the second one is the feature engineering. Feature engineering, that means based on some feature we have, we can aggregate more than two features and try to find another feature. Okay, feature selection. That means so we cannot work with all the feature provided in our dataset. We need just to select the best one. So based on some techniques of scale, for example, technique of scale, for example, to see what is the relationship between this target and independent feature. And the last one or the last phase here is the model deployment. That means we make our model into production. Well, as we do every time here, as we see, we have the packages we can need for now. Import pandas, also import numpy. We also for visualization, the basic one I use here, Matplotlib, and for scientific visualization, statistics between brackets, I use it CBOR. Well, I use this syntax here. So the pandas provide for us this set option to display the maximum, okay? The maximum of columns and the rows. We can do that. So we using this syntax when we have a huge data. But here in our case, we don't have much of data. You can see that a bit after. Well, here I starting with this train data, okay, or train CSV. It's mean the file for training to discover what we can do. So as we see here, I creating this variable, call it dataset equal to pd.readcsv train.csv. Here, because I applied function of readscsv because the extension or format of our file is csv. For this reason, I use this readscsv here. And for anyone want to discover more about this function we can use to read in the data, you can go to my playlist print the shape. Okay, print dataset. This variable we have here. Put shape function of shape. Provide for us two parameters. First one is the number of rows, and the second one is the number of columns we have. So in our case, we have small dataset as we look in here in this uh, train file. Okay, see the number of rows, 1416, and we have 81 number of features. Okay, well, I write by default the top five recorded by default using without this function of head. Okay, well, this is the data we have. We have ID, we have MSS class, we have MSS zoning with footage, main area, street, line, road shape, non-core, utilities, config. Okay, we have lot, we have 81 feature, that means big one, big number of features, and we can see more than that. Well, this is all the features we have. Okay, we have a lot of features. When we see here, we have some features with a huge number or great or big numbers compared to other one. Compared to solve, or we have the type of string variables here, as we see is the cell type, for example, or cell condition. Well, so let's continue. So in data analysis, because here, if as I showed you before, we can follow the steps of the life cycle of the project of data science. So in this tutorial, I want to just show you data analysis. Okay, and another next videos tutorials I can show you each one of these steps or the steps we have. So okay, well, here in the analysis, we will analyze it to find the outcome of stuff. So in this phase of data analysis, we can just or the first step we can do is to track the missing values. Okay. The second one is to see all the numerical variables we have here. Second one is the distribution of the numerical variables. We need to see the distribution we have here in this variables. Fourth one is the category variables. We need to select, trace just, filter just the categorical variables, cardinality of the category variables. We need also to check in the outliers, and the last one, the seventh step here is the relationship between independent and dependent features. As I told you before, here is this is the here is the beginning of selection of features, because I told you before we can now work on all the feature provided here. I'm just selecting the best one. Okay, because if we have if we're using just some feature with a weak relationship, that means we the the, the the prediction or forecasting of our model, it will be weak also, or it will be weak, noisy. For this reason, we need to apply this phase of feature selection. Well, let's start here with the missing value. Well, here as you see, I'm writing that this comprehension. Well, this is the syntax. We have features with non-value. This is the value. This is the variable one I create now. Features with a non-value. Here are the features. For features here, I using this variable just for looping in our dataset or our data frame. Okay, features for feature in dataset.column, because now I interested just with columns. For this reason, I apply this function of columns here attached to this dataset. Well, I need to check in this condition inside of this list we have here. If the dataset of these features, okay, is new, and the total of this null value is more than 0. Okay, that means if we have one null value, two null value, I need to store it in this variable. Okay, here also I discuss this kind of this comprehension in my place of Python. Each one want to understand more that, so we can go to my playlist of chicken again. I can find the answers of all these things. Well, if we continue in this process, we look on with me this loop we have here. For feature individuals we know, that means I want to loop in over all these variables we have here. Okay, So for feature in features, I need to print uh, I need to print this all these numbers we have here. Okay. Well, to print the feature does mean the name of a column we have here because as we see here, I just interested with the name of columns we have here. And the second part inside of this function of print, I use integer round just to make the numbers of values I want after the comma. Well, nip.round dataset of feature is nil dot mean. I want just the mean of the null value we have here. Okay, I need the mean of all these null value for each feature we have here, and they want four numbers after the comma. And here I want also print these meshes to give me to understand, or for anyone writing this code can understand this is value, or this is the sentence can help us to understand this this code or this sentence. Okay, so if we look in this result here, this is the return after running this cell. So we have lot French, so 0.70% of the missing value we have here in this amount of all these features. Okay, for load frontage we have 0.70% of missing values. For LE we have 0.93. That means a huge rate of missing data in this feature or in this variable. So the same things happen with these other variables or features. We have mass array type. We have also mass venue area. We have event call. Is empty code. So we see the code of all our variables. So for this reason I told you before, we need to have a domain knowledge. Maybe here I need also architecture can help me to understand all these codes we have here, because it's the feature is not a real name of this feature. Okay, we have just code. But also now what is interesting for us is to discover the data based on this feature. Okay. Well, we look in different rate of missing values for each variable we have here. Well, if I run also this feature with now, this is all the okay, this is all the features we have here. Okay, this is the features we have. So, well, if we continue also, well, since the many missing value, we need to find the relationship between missing value and sales price. That means we need to discover what is the relation we have between these missing values and sales price. Okay. Well, to do that, we are creating here also this loop for feature in the features with now. So I need to look over this variable content just missing value, or the missing or features content the non value. Well, creating another variable here called the data. Go to dataset.copy. I creating a copy from this dataset. Okay, this is the copy of the dataset I stored here in this variable data. Well, let's make a variable that indicate one if the observation was missing, or zero otherwise. That means if the data is nil, okay, not we have null value here. I need to replace it with one. Okay? Let's make a variable indicate one if the observation was missing. That means I replace one here in the case of missing of data, and zero otherwise. That means if not, we replace it with zero. Let's calculate mean sales price where the information is missing or present. Well, if we look on this piece of code also, okay, sorry, okay, no, data.group feature. I need to group by all this data here. I need to group it by features. Okay, the features here, and I need sales price. I need the median of sales price, and I plot it as a bar. Okay, we have also this ability to plot the data directly when tracing the type of plotting we want. So in our case, we have the bar and the check. Now I want to see what's happened. Well, if we are starting with lot frontage, if we look in here, this one, okay, sorry. we look in this load frontage, this is the title. Okay, if we look in here in this axis, we have two values. We have 0 and 1. I tell you before, if we data is missing, we need to replace it with 1. As we see here, we have a lot of data is missing here in this one range, and we have also 0 here. See, not missing value. Also, the same thing with LE feature or LE variable. So if we look in here, we have missing data, replace it with 1, and otherwise, or the other side, left side here, we have 0 for the non-missing value. So the same thing with this mass binary type. Okay, if we look in here, we have 0 for. I'm so sorry. Okay, well, so for mass binary type, we replace the null value with 1 here. Looking in this bar, we have is around 200,000. Okay, to 200,000. Yeah, 200,000 of missing value here. If we look in the other side of the website here for 0, that means the null value here we have around between 150,000 and 170,000 maybe. Okay, well, if we look in for the other one here, okay, let me show you the STM qual feature. So we look in here, uh, we have half of missing data. Okay, that's why here if we see the bar of 0, we have uh, second bar in the half of the first one. That's why we're gonna make an observation here. We have the half of the data here. Well, if we continue, also for this BSC cond, assembly, okay. Also for the exposure, okay. This means this missing value here. We based on this missing value here, we predict the price here because in this y-axis we have the price house. Okay, we have this name value here and we have the price here. We need to see what is the relationship between this one. How the price is impacted by the missing value. Well, if we continue in the same feature, PSTM point type 1, we have the same things here. We see how that or this missing value, how can change the price or the target value. Okay, we have these things for all the features we have because we use it here the loop. That means I need to loop it over all my columns we have. Okay, so that's for all columns we have. Well, here with the relation between the missing value and the dependent variable is clearly visible. So we need to replace the null value with something meaningful, which we will do in the feature engineering selection. Okay. When we come in the next tutorial, we go in this part of feature engineering. We can do this. Can replace this missing value with something meaningful because we cannot give for our model this missing value and try to make a prediction. Here we see how much of IDs of houses we have. Okay, some like function of sheet. Well, here, okay, sorry. If we go in this part of numerical value variables, so how we can distinct this numerical value from the others one like categorical or continue variables. Just with a simple syntax. That's easy. We are creating another variable here called numerical features. Inside of this list comprehensions, I create this one. Okay, feature for feature in dataset columns. That means I look over all the name of features I have, and I need to check this condition. So if the dataset of this feature and the type of this feature is different of O, string, that means it's numerical. Because this is the syntax in Python. It's one of the syntax we have to select the numerical variables. Well, we have the syntax, question mark, while true, big O between codes. Well, we have print the number of variable. We need to see the land, how much of the numerical features we have in this data set. Well, we have data set numerical feature, but we have here 38 number, 38 feature numerical variables. So if we look in here, this is all the features we have, or the type of feature. If you look in here, we have not the string type. Okay, we have, if we look in all, we have just numbers here in this feature. Okay, so that's what we look in here. That's what we see. So here, yeah. Well, we have also some temporal variables. Example, that time variables. In most of data, okay, we need to focus in at that time. Okay, this kind of features is very important for any data set. Okay, like also well, from dataset we have 5-year variable. So if you check it, it will show you now. We have extract information from the time variable like number one, number of years, or number of days. One example in this specific scenario can be difference in years between the year the house we work at the year that house sold. Will be performant analysis in the future again, which is the next video. Well, I will show you now how we can see the difference between how much of time this house is have the age of house. Okay, because we have variables of time. That means we have the years of build and the years of sold. That means we need to measure the, the the age of this house. Well, here if you're looking, I create another feature here for time. Um, feature for feature in the numerical features because I want to trade because by default here this time variables is included in the numerical feature. Okay. Well, for this reason, I need to select those time variables from these numerical features. Well, feature for features, numerical features, if the year, because this is a constant here, okay, year in the feature, if this year in the feature or year in the feature, we need to put it here in this variable. And we are, after running this cell, we have all the time variables we have here. Okay, year of build, year of remove, garage build, and years of sold. Okay, this is the fourth variable of time we have. If we continue here, so for feature in the feature, brand feature dataset feature dot unique. That means we need to see not duplicated years. So for each one here, for a year of build, for example, we have all these years inside of this list is not duplicated. Why? Because I call this function of unique. I want just a single or identical year, okay, not duplicated. When I using this unique function here, that's what I see here in this list. Well, the same things happen with other variables. Year of add or remove, for example, your garage build. Also, we have these years, okay, and also for your salt. See the year of salt here. Okay, we have just 5 maybe. Well, let's analyze in the temporal that time variables. We will check in where the relation between years, the house, sold, and the sales of price. So we need to see this the relationship exists between these temporal variables and the target one. That means the year of or the sales price. Well, here, let's see, I group by year of sold. Okay, sales price. I want the median of prices and plot it. This is X label. I call this year sold in the X axis. Okay, and for Y axis we have the median price house. That means the median is not the high or minimum. It's the median of price. And also I give for this figure a title called house price with years sold. So if we look in here in this curve, okay, in the bottom we have the years, and here in the the left side or in the y-axis we have the median house price, and we look here. There's all the numbers we have in our price. Not all, but it's the most frequent prices we have. Well, if we look on this curve here, okay, based on this year for 2006, for example, we have this curve. It's in rise, okay, until here, it's 2070. Maybe my own hypothesis for explain that this part of this curve it's caused by the recession of 2008, because the recession started from this year 2017. If you remember, recession decrease we have in the 2008. So after that, we look in the price of these houses. It's decrease here and here by years. Okay. So if we look in this relationship between this median house price and this y-axis that's made here of sold, we look in this curve is decrease here in this part from 2017 maybe, okay, and which by time the price is decreased. Maybe we have a lot of reasons can explain that, but for me, because I don't check in before this one, well, my own